Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 4 of the second lesson on reciprocal trig identities, and in this video I'm just going to be solving one final example of a Pythagorean squaredy swappy identity. Okay, so here we go. We're going to solve cosec theta plus pi over 4 plus 1 minus cot squared theta plus pi over 4 equals 0. And look at the range of values, it's 0 to 2 pi. So straight away I need to be noting that I'm in radians mode for this, and the first thing I do before anything else is I take my calculator and I make sure that it is in radians mode. Done. Okay, so I've got a combination of cosec and cot, so I'm going to be using the identity 1 plus cot squared theta equals cosec squared theta. But because it's cot squared theta that I want to be swapping here, I'm just going to have to rearrange this slightly to be cot squared theta equals cosec squared theta minus 1. Now I just need to be careful here when I do this substitution. Cosec of theta plus pi over 4 is not going to change. Plus 1. Now minus, make sure you put a bracket round the cosec squared theta plus pi over 4 minus 1, so that you don't forget to allow for the minus in front of that bracket. As in the previous video where we talked about if you have cot squared theta equals cosec squared theta minus 1, whatever you have here for theta and theta is consistent, it's the same, and it doesn't change that minus 1. So the fact that I had cot squared theta plus pi over 4, that was replaced by cosec squared theta plus pi over 4 minus 1. So the bracket has stayed the same, but doesn't affect that minus 1. So let's just tidy this up a little bit then. So we've got cosec of theta plus pi over 4 plus 1 minus cosec squared theta plus pi over 4, and I'm subtracting negative 1, so what I've actually got now is plus 1 equals 0. So let's just tidy that up by adding those two ones. So I've got cosec theta plus pi over 4 minus cosec squared theta plus pi over 4 plus 2 equals 0. And what I'm just going to do, because we can see how that's a quadratic in terms of cosec theta, I'm just going to change the sign so that my coefficient of my squared term, cosec squared, is positive. So cosec squared theta plus pi over 4 minus cosec of theta plus pi over 4 minus 2 equals 0. So as I've been saying throughout these videos, you might be happy factorising it from there. However, what I'm going to do in this case is I'm going to let y equal cosec of theta plus pi over 4, which will change my equation to y squared minus y minus 2 equals 0, a much more normal quadratic for you to factorise and solve. So y minus 2 and y plus 1 equals 0. So therefore we have y equals 2 and y equals negative 1. But of course it's not y that I'm interested in, it's cosec of theta plus pi over 4, which equals 2, and it's cosec of theta plus pi over 4, which equals negative 1. So each of these two equations is going to give me values for theta. However, first thing, cosec, so I need to change cosec to sine, because that's the reciprocal identity. The bracket doesn't change, but 2 is going to change to 1/2. I can then do sine inverse of 1/2, which is pi over 6. and my second solution for sine pi minus is going to be 5 pi over 6. Now, importantly, that means that theta plus pi over 4 is equal to pi over 6 and 5 pi over 6. And when I subtract pi over 4 from each of these, now, if I subtract pi over 4 from pi over 6, I'm going to get negative pi over 12. And if I subtract pi over 4 from 5 pi over 6, I'm going to get 7 pi over 12. I'm happy with that one. I'm not happy with that one. And the reason I'm not happy with that one is not because it's wrong, it's not an incorrect solution, but it is an invalid solution because it's not between 0 and 2 pi. So what do I need to do? Well, I need to come back to here, where I've got my two solutions, and I need to add another 2 pi to this one, which means I would have 13 pi over 6. So 13 pi over 6 would come in here, and then when I substitute pi over 4 from that, I'm going to have 23 pi over 12, which is a valid solution. So what I'm just going to do is reject that one for not being inside the range. Secondly then, over here, cosec theta plus pi over 4 is negative 1. Cosec is going to be turned into sine. Bracket stays the same. I'm just taking the reciprocal. And now the reciprocal of negative 1 is still negative 1. Now, sine inverse of negative 1. So if I do sine inverse of negative 1 here, it's negative pi over 2. So sine inverse of negative 1 is negative pi over 2. I just need to think about what that looks like on the cast diagram, just drawing it quickly out here. So 0, pi over 2, pi, 3 pi over 2, and all the way back around to 2 pi. Now negative pi over 2 is going to be here, on the line, on the axis. But rather than going clockwise in the negative direction, I'm going to go anti-clockwise in the positive direction, which is 3 pi over 2. And it's the only solution because it's on that line. So what I have down here, I have theta plus pi over 4 equals 3 pi over 2. When I substitute pi over 4 from that, I'm going to get that theta equals 5 pi over 4. And that is my third solution for theta. So 3 solutions for theta, 7 pi over 12, 23 pi over 12, and 5 pi over 4. So 3 valid solutions to this equation. If you want a little bit more of an explanation as to what happened here, when we did sine inverse of a half, and it came out as pi over 6, that would go here on my cast diagram. This would be pi over 6. But if you subtract pi over 4 from pi over 6, you're actually going to go to the negative bit, which I didn't want. So by adding 2 pi to pi over 6, what I've done is I've gone all the way around the cast diagram again, and then when I've taken off the pi over 4, it's taken me back here, which is less than the 2 pi, and you might have thought, oh, 23 pi over 12, that's close to 2 pi, and it is, because you're going to be about here on your cast diagram. So that's what's happened there. So key points to take from this video, if you have theta plus pi over 4 in the bracket of the identity, you'll get it in the bracket of the substitution. But other than that, standard trig squared swappy equation, just don't forget to put yourself in radians mode. Job done.